Hi guys, my name is Karthik and I am from executeautomation.com and welcome to another video from Execute Automation. And today we're going to talk about Specflow's all new extension available for Visual Studio 2022. And in this video, we are going to talk about not just about the new extension of Visual Studio 2022 of Specflow, rather we are going to create a project using Specflow and then we're going to write a simple scenario with Specflow and also we're going to create a Selenium code to support the parallel test execution and run the Selenium test on a Docker container, which is going to be completely parallel. And also we're going to see the Specflow's awesomeness in this whole video. So you will see all these details in this particular video. So this is going to be the agenda that we are going to be talking about. So the first thing which I'm going to do is we are going to start the Visual Studio 2022 itself. So all I'm going to do is I'm going to open the Visual Studio 2022 preview over here. So the first thing about the Specflow installation is very simple. You can click this continue with code. You can go to the extension, go to the manage extensions over here. And if you search for Specflow, you will see that Specflow for VS 2022. So make sure that you install that. Since I have already installed it, there is a tick mark here with a green color symbol, which means it's already installed. And with this installation, I can now create a project with this particular project template, which is nothing but the Specflow project template that you can see over here. So I'm going to choose this particular project template. I'm going to hit next, and then I'm going to give a project name over here as Specflow demo or Specflow project Selenium, something like that. And then I'm going to hit create. And make sure that you choose the framework as .NET 5 instead of .NET 6 because the .NET 6 support is yet to happen from Specflow team. So make sure that you select the .NET 5. And then there is a test framework, which is you can choose any framework, NUnit, XUnit, MSTest, or Specflow plus runner. I'm going to choose the NUnit. I'm going to leave the add fluent assertion library as it is, which is going to be very helpful while we do the assertion itself. And then I'm going to hit create. This is going to create a new project with all the scaffolding of the code from the Specflow's greatness. So you can see this is the one of the awesomeness that you can see in Specflow. You get all the scaffolded code structure that you really need to have while you start working with the Specflow itself. So you get the feature file, which is going to look something like this. And you can see that all the step definitions are already mapped, which means the step definition is something over here that is sitting is all mapped with this particular feature file over here. And you can see that there are some changes over here, something like go to definitions, define steps, and rename steps. So this is pretty cool. So now the menu is more refined with the new logos and stuff. So you can just hit the define steps. You can see that the steps is already been defined. You don't really have to redefine it, but you can do the go to definitions like this. It is going to take you to this particular step definitions. And you can also do all sorts of things pretty much exactly like how we used to do in Specflow before. So those things are going to remain the same. And you can also see that the test explorer is now going to show you the test of the Specflow over here, something like this. So everything is coming up and now you can run the test from here, but it is not going to run because you will see that the step definitions is going to show you the throw new pending step exceptions. That's the reason it is not going to basically execute, which is fine. So everything is pretty good. The next step of our agenda is to install the Selenium and then start writing the Selenium code to run the test in parallel on the Selenium grid, that to the dynamic Selenium grid. So all I'm going to do is I'm going to add the NuGet packages and then I'm going to search for Selenium and I'm going to install the latest Selenium, which is nothing but the Selenium 4.0.1. And once I have the Selenium, then I can start working with the Selenium itself. So I'm going to first create the driver code, which is going to hold my Selenium WebDriver. So I'm going to create a new class file. I'm going to call this as WebDriver library or something like that. And within this WebDriver library, the first thing which I'm going to do is I'm going to use one of the Specflow's awesomeness, which is nothing but the context injection of the Specflow itself. So this is the most important thing that you need to do, because while we carry this WebDriver library from one class to another class, that too while using it for the parallel execution, we need to hold the instance of the WebDriver object across the class files in the whole project, which we can do much easily using the context injection of the Specflow. So I'm just going to use the exact same thing. I'm going to create a scenario context here. I'm going to hit control dot and you can see that it's going to show me the using tech.specflow, and then I'm going to create the scenario context and I'm going to hit control dot once again, which is going to ask me to create and assign a property or a field. So I'm just going to use the field option And because this is going to be a private variable, I'm going to use the underscore there, and I can use the underscore here as well. That's it. This is the only thing. I can use the expression bodied constructor to make the code look more simpler. So this is the first thing which I need to do on the WebDriver library. And once I have this thing, I can then start creating a simple code. And because this particular code is nothing to do with the Selenium itself a lot, I'm just going to run through pretty quickly so that you can see how we can write the simple codes on spawning the Selenium WebDriver with different browsers and stuff. So I'm just going to write a method, something like get browser options, which is going to give me the browsers based on the browser name that I'm going to passing in. So I'm just going to open the Firefox browser, Chrome browser, Edge Chrome browser, and Safari browser using their browser names. I'm just going to return the options here. And then I'm going to create a setup method, which is going to perform the setup operation itself, which is going to be this one. So I'm just going to call the iWebDriver over here. And then I'm going to call the remote WebDriver, which is going to be calling my Selenium Grid over here. And then I'm going to pass the capability that I have got over here from the get browser options, which is this one. And then I'm going to probably declare a driver here. So this is the setup operation that I need to do for my WebDriver to get ready with the remote WebDriver option. So this is going to connect with the Selenium's grid that I'm going to be spawning pretty quickly. And the next thing is about the Specflow's hook. So I need to have a hook folder, something like this, which is going to hold the before scenario and after scenarios and stuff. So I'm going to create a class file. I'm going to call this as test initialize. And this test initialize is going to hold the before scenario. And if I hit control dot, you will see that it's going to bring you up the using tech.specflow, and probably going to call this as public void start WebDriver, something like that. And I'm going to call the WebDriver library, the library that we just wrote over here. And I'm going to call this as new WebDriver library, something like this. And I need to pass the scenario context over here. So once again, as I told you, the scenario context is the one which I'm going to be using as a context injection of the Specflow. So I need to have the scenario context across the classes wherever I'm actually going to be using the WebDriver itself. So I'm going to call the scenario context once again, hit control dot, and then I'm going to create and assign a field, something like this. And because this is going to be a private variable, once again, I'm going to be using an underscore over here just for the naming convention. And I can pass the underscore scenario over here within my WebDriver library class. That's it. So that's about the code that I'm going to be passing in. Let's give some real estate so that you can see this clearly. And once you have that, I am then going to store this particular WebDriver's instance in my scenario context. So this is the most important thing that I need to be doing. If not, that particular WebDriver object is not going to be available for you. So I'm just going to store the WebDriver library, something like this. I'm going to give a name for this WebDriver library. Probably I'm going to call this as WebDriver library, something like this. That's it. So that's about the starting of the WebDriver. And once I have this, I'm then going to even kill the WebDriver, which is nothing but stopping the WebDriver. So I'm going to use the after scenario, and I'm going to call this as public void kill driver, something like this. I mean, you can name whatever that you wanted to. And then I'm going to call the scenario context dot, probably not the set. I need to do the get operation, something like this. So these are all the Specflow's awesome features that we have got. So I'm going to get the iWebDriver, something like this, and I'm going to get the WebDriver that I have created in my setup method. So let me just go and show you that particular stuff that I just did. So you can see that on the setup method, I did the scenario context.set of the driver of the WebDriver. So this is the WebDriver that I need to use to kill the Selenium WebDriver itself. So I'm just going to pass this guy, and then I'm just going to do a quit operation. And because we are passing the type as an iWebDriver, it is very, very easy for us to call all the methods like quit or find element by or whatever it is. So that's working fine for us as well. Use the expression bodied member to make this code look more simple and cleaner. That's it. And the final thing is we need to implement the feature file and then the step definition implementation, and then we can run the test and see how it actually works. So in order to show this particular stuff, all I'm going to do is I'm just going to copy some of the feature files and step definition that I have already written like these. And this is going to be the scenario that I have written. And also I'm going to create one more feature file. I'm going to call this as probably login again, something like this. And this login again is going to hold this guy. Let's give this feature name as login again. And the scenario outline is going to be application again, something like that. Test login functionality of application again, something like that. The test is very, very simple. All it's going to do is it is going to navigate to the application with the following browsers, like all the browsers that it has got. And then it's going to perform a click login link. And then it's going to enter the username and password and click the login button. That's it. This is the only operation that this test is going to do. And the application that we are going to be choosing is going to be our most familiar eaapp.sami.com website, which I can show you how it's going to look like. This is the application, the eaapp.sami.com. So it's going to click the login link. We're going to enter the username and password over here. And then we're going to click this login button. That's it. So this is the only operation that we are going to be doing over here. So once this is done, let's try to start implementing the step definition itself. So probably the two things which I need to do is I need to rename this to login, and I'm going to call this particular step definition as login steps. And I'm going to get rid of all these implementation that it has got because I have nothing to do with this particular step definitions. I'm just going to save it. And now if I come back to this particular scenario outline, I can just right click and then I can do this define steps, and it is going to show me all the steps that I need to implement. So I can copy this particular step definitions in the clipboard, and then I can go to the solution explorer and go to the login steps, and then I can paste it over here. So you can see that it is going to show me all the steps that I need to be implementing within my code. And because I am actually using a table structure, something like this over here, I need to somehow use another Specflow plugin, which is very, very handy. And I have talked about that a lot. I'm just going to show you what this particular plugin is going to do. So if you just search for the Specflow, something like this, you will see that there is a plugin called a specflow.assist.dynamic. This is pretty interesting plugin. So make sure that you also use that. I'm just going to accept it. And I have already installed it, I guess. So if I just close and if I go over here using this particular plugin, I can use a dynamic keyword to create a data from the table dot create dynamic instance, something like this. So this particular dynamic instance is going to be coming from, if I hit control dot, you will see that this is coming from the tech.specflow.assist. So this is the package we just installed. That's it. And once you have that, I can then start calling our Selenium web drivers and do all those stuff. So I'm just going to create one more constructor over here for calling our context injection, which is nothing but the scenario context. For dot, once again, create and assign probably a field. And once again, this is going to be underscore. Also going to be calling the iWebDriver. I mean, we can refine this code even further, but I'm just going to be using very, very easiest way of writing the code, something like this. Control dot. And once I have this particular driver object, I can then go over here. The first step is going to be given I navigate to the application with the following browsers. So I'm just going to do this driver is equal to underscore scenario context dot. And you know that because we are going to navigate to the Selenium's WebDriver, I need to have the WebDriver library class, which is going to be the WebDriver library class that we just created. Control dot, this guy. From him, I need to call the WebDriver library object, and I need to call the setup method where I have to pass the browser name, which is going to be the browser name that I have passed in on the table of this particular guy. So you can see that, oh, so it's browsers, not browser. So I need to pass this as browsers over here. And you can see that that's it. That's the only thing that I need to do over here. And once I have this particular driver, I can then do this driver.navigate of the URL which I'm going to be navigating in, which is going to be the http://eapp.somi.com. This is the browser. Probably I can just do this driver of URL is equal to this as well. I can do it this way as well, which is cool. And once I have this, I can then write some of the code that I have already written. I don't really have to keep repeating the same steps again and again. So I'm just going to paste this code over here, which is going to perform the click login, entering the username and password, and clicking the login button. That's it. These are all the steps over here. So let me try to rebuild the solution, and you will see that we are going to get the login again feature and the login feature over here. And you can see that all these step definitions are currently mapped. Now the purple is turned into a white color here, which means all the step definitions are mapped as well. And now you can see that we could able to potentially run the test. So all our agenda operations are almost there. The final thing is we need to spin up the Selenium grid, which is the Selenium's dynamic grid. I've already talked about the Selenium dynamic grid. If you have not heard about Selenium dynamic grid, so please go ahead and search for Selenium dynamic like this. You will see there is a video available which I have released like 3 weeks before. So I'm going to use the exact same thing even over here, and I will show you how we can run that. So in order for that, I'm going to open the Windows terminal. So probably this is the one, and then I'm just going to call our cd, I guess it's Selenium grid docker, and ls. Yep, I have the codes, so I can just do a docker compose. So this way it is going to start the Docker container here, as you can see, and then it is running all the containers for us over here. So the Selenium hub and the Selenium docker node docker. And once we start running the test, it is going to spawn multiple containers, and it's going to create the instances and all sort of things which we have already discussed. So if you go to the localhost 444 over here, you can see that there is a Chrome session, Firefox, and the Edge Chrome sessions. And because there are no tests running currently, the session is currently empty. So let's try to run our test and see what's going to basically happen. So I'm just going to go and I'm just going to run all the tests over here. Let's see what's going to happen over here as well. The tests are currently failing. I guess there is a problem. It says that the WebDriver library was not found in the given key of the dictionary. So let's see what's really happening. So this is WebDriver library. I guess the problem is because we have not defined the binding for the hooks over here. So I forgot that. So let me try doing the bindings over here of the Specflow. If not, the Specflow is not going to recognize this as the hook. So we're going to do that, and let me try running this second time. Let's try to run, see what's going to happen on the Selenium grid side. So you can see that the Selenium grid is starting to spin up over here on the dynamic Selenium grid, and you can see that it is currently starting to run. And because the test is currently running in sequence, it is running each and every step definitions over here like one by one, and we can see that particular session as well. So you can see that there are some sessions coming up. So there is one session at the time. It is not running like multiple sessions. So every time it is going to run just one session for us. So you can see that the test has got successfully completed. And then it is running the second test for us in different browser, which is going to be the Firefox browser. So it is running the test on Chrome browser as well as on the Firefox browser for us, but it is running in sequence. Now, in order to run this particular test in parallel, the last operation that we need to do is to actually call what is called as the parallelizable attribute of NUnit, which will make this test to be running in parallel itself. So in order to do that, all I'm going to do is I'm going to go back to this test initialize once again over here, and then I'm going to be calling the assembly operation of the parallelizable attribute. So I'm just going to call the parallelizable attribute over here, which is going to be from the NUnit framework. And then I'm going to call the parallel scope as the fixture over here. That's it. I'm going to save this. And now if I run all the tests over here, This time the tests should be running in parallel instead of running in sequence. So you can see that there are two tests running in parallel at the same time from two different feature file. And now if I go to the grid, you will see that the sessions this time it's 2 instead of 1, which means it is running things in parallel for us. So it is running one test in Chrome and in Firefox. Probably it's going to run in Chrome and Firefox in sequence, but it depends on how we have defined the tests. So you can see that the first execution is done, and there is going to be another sessions pretty soon, probably. Yeah, there we go. They're running in Firefox right now. The first tests were in Chrome. Now they're running in Firefox, which is pretty cool. So now we could see that the tests are running in parallel, and we could see that the awesomeness of Specflow running in parallel using Selenium's Dynamic Grid and using Visual Studio 2022. And it's all happening in Windows 11 at the moment. So this is the Windows 11 that I have installed in my machine. And you can see that all the awesomeness that you can see is all coming through pretty well with the latest version of Specflow Extension in Visual Studio 2022. So that's it, guys. That's the big story in a short video. But once again, thank you very much for watching this video, and hope you really like how to use Specflow in VS 2022. Thank you.